Hello and welcome to Medical Dialogues. I'm Anshika Mishra. Here's what I bring to you from the world of medicine. Scientists identify enzyme crucial for priming cells to combat autoimmune diseases. A new study from the University of Massachusetts, Amherst, focuses on the rare autoimmune disorder, aplastic anemia, to understand how a subset of cells might be trained to correct the aggressive immune response that can lead to fatal autoimmune disorders. The research published in Frontiers of Immunology identifies a specific enzyme known as PRMT5 as a key regulator of suppressive activity in a specialized population of cells. The human immune system is remarkable, but in rare cases like aplastic anemia, it can malfunction. In such condition, immune cells such as the Th1 cells mistakenly attack healthy stem cells in the bone marrow, disrupting blood cell production essential for fighting infection, carrying oxygen and preventing bleeding. What we want to do is to make a super suppressive cell, says Nidhi Jaden, graduate student in the Department of Veterinary and Animal Sciences at UMass Amherst and the paper's lead author. If someone is suffering from an autoimmune disorders, we can use these super suppressive cells to dampen the aberrant immune response instead of drugs.
Are you also aspiring to excel in medical journalism and delve into the intricacies of health and medical reporting? Explore our comprehensive course on medical and health journalism available at the Medical Dialogues Academy. Learn from industry experts who possesses in-depth knowledge and experience in this field. For further details, scan the QR code provided or access the link in the description box below.
Sinusitis may be connected to a 40% elevated risk of rheumatic disease. A study published in the open access journal RMD Open revealed that the common inflammatory condition sinusitis is associated with a 40% increased risk of subsequent diagnosis of rheumatic disease. The risk is particularly notable in the 5 to 10 years leading up to the onset of symptoms. Sinusitis involves inflammation of the sinuses, the air-filled cavities behind the cheekbones and forehead. Previous research suggests a connection between lung irritants like air pollutants and respiratory infections and conditions like rheumatoid arthritis. However, it remains uncertain whether sinusitis could predispose individuals to other rheumatic diseases. The scientists conducted a controlled study using data from the Rochester Epidemiology Project, a medical records linkage system covering over 500,000 individuals between 1966 and 2014. The study sample comprised 1,729 adults newly diagnosed with systemic autoimmune rheumatic disease and vasculitis, matched with 5,187 individuals without rheumatic disease, based on age and sex. Patients' history of sinusitis before rheumatic disease diagnosis was analyzed in time segments of 1 to 5 years, 5 to 10 years, and over 10 years. Factors such as age, BMI, smoking status, sex, race, and ethnicity were considered in the analysis. Scientists find leaky gut may be linked to faster biological aging. Recent research published in the journal Microbiome revealed a link between viral damage to the gut and accelerated biological aging. The findings suggest that this association can lead to increased gut permeability and premature aging of systemic and intestinal tissues, particularly in individuals with chronic HIV infection. Accelerated biological aging, when the body ages faster than its chronological years, increases susceptibility to serious health conditions typically associated with older adults, such as cancer, heart disease, brain disorders, severe infections, and decreased vaccine efficacy. The gut microbiome and its possible leakage into the bloodstream are implicated as key factors of this aging process. Dr. Abdel Mohsen, Wistar Institute's associate professor, along with his collaborators, investigated how gut leakage can impact the immune system and lead to chronic inflammation, which may accelerate aging by analyzing samples from people living with chronic HIV infection, which is known to potentially accelerate biological age. This makes it a suitable model to investigate mechanisms of accelerated biological age in people living with chronic conditions. Thank you for watching. Stay tuned to Medical Dialogues for more updates.
Never miss a medical update from Medical Dialogues. Like, subscribe, and press the bell icon.